So just to recap, in the second module, we're actually working with one of our areas of interest concerns the legal aspects of incident handling versus evidence collection when legal matters come up, right? So network forensics is basically focused in two realms, if you will. One that supports technology operations and the efficient use of network resources and systems, and then the other concerns how to deal with events that become incidents. So when an event is there's a pattern of events that reflect an incident. If it's handled and it's determined at a later time that a legal matter needs to be pursued, or even an official matter internally for that organization. You know, there are internal investigations. If you recall, in digital forensics, there was review of different levels of investigations. Yeah. Does everybody remember private versus public and so on?
Yeah, I remember.
Yeah, when something becomes public, it's often because there's a legal matter that's been encroached and it requires review and or investigation and or prosecution, and then court cases, civil or criminal, so it gets pretty sticky. Once you get to the courtroom, it's pretty much a matter of public record because court records are public, right? Even if they're sealed, there's still a record that something occurred and the parties that were involved were, you know, subject to review and consensus on an outcome, right? So even if court records are sealed in a civil case, you know, oh, there's an out-of-court settlement. You know, they've decided that everything has been squared away and there's non-disclosure agreements that are signed. All that becomes kind of public. So private internal versus public. And incident handling versus, so this is preemptive and preventive in nature. A primary aspect of incident handling after detection, right? So you set the stage for proper detection once an event is detected. If it's judged or determined to be an incident because there's a pattern there, then what occurs is that there's an assessment of the nature of the incident and then prompt action to mitigate or reduce the damage and then to recover. And then there's lessons learned. So there's a incident handling process that's followed, a recommended set of procedures that's followed in the case of incident handling. The moment, just as in digital forensics in CSC443, we taught you that the moment you have something that is potentially legal in terms of requirement, then you kind of flip into a different mode. We also mentioned that client-side artifacts exist on the local host, certainly, but that there's also client-side artifacts. There are also artifacts about the incident that exist elsewhere on the system and with alternate hosts. So when we're talking about client-side artifacts, even though the focus of the artifact is about a specific host, that information could originate from a different source, right? A different host and across different networks. Does anyone have any observations or questions or comments about that assertion at this time? Hearing none. In this module, we want to explain how network forensics differs with legal and incident handling interests. And so what we're going to do is sort of set the stage in our hands-on investigation so we can take a deeper dive with priority, right? And then what we want to do is call out the salient interests depicted in chapter 3 in the lead scenario. So if we look in the textbook, we're talking about the hypothetical adversary reflecting on how he or she couldn't operate for very long during business hours, and he or she could engage other hosts in the network environment in order to do some of the unauthorized activity, right? So if you read that scenario in chapter 3, that's something that we're going to call out specifically in the study guide. And I will have the first draft of the study guide completed by close of business tomorrow. So we'll post that in here inside the references, but we're basically keeping notes on that draft right now. One of the things that we want to take the time to do before we finish up our content review this week, on Wednesday, we're going to spend quality time reviewing the different types of network firewalls and the history of development. So when you look at network security measures, the first firewalls were very simple devices and were not context capable. They were not behavioral capable. So there's this evolution of network firewalls, but there's also an Achilles heel. So Wednesday is going to be an important class because we'll be talking about firewalls and focusing also on the Achilles heel of most network firewalls and underutilized features. So there are additional features on firewalls, or rather, there are additional placements of network firewalls that are often ignored in an organization, and that leads to all sorts of gaps in an organization's ability to detect incidents, right? So where and how those firewalls are deployed makes a huge difference. And you're going to see a piece of this in our solution. So you're going to realize there are some gaps and there's a limit to the amount of information we can collect with a traditional placement of a firewall, right? And of course, the last learning objective for this module is to identify and utilize evidence collection standards and methods, and then to identify and utilize evidence handling standards and methods. So part of what we're doing in the assignments and solution is to collect evidence, and then in the other part of this is how do we properly preserve the evidence, right, for future reference. So I hope by this time you've completely scoured chapters 1 and 3 in the textbook, and we're going to return to this idea about local DNS and what we can glean later after we've completed the rest of this. So if you have not yet posted a submission for the 2.1 assignment, I want to encourage you to do that now. And then that's also true for 2.2 and 2.3. I wanted to spend a moment, though, talking about this because considerable time and quality was devoted over the weekend to produce the solution instructions. Has everyone here had a chance to at least glance through or take a first look at the solution instructions?
Yeah, it is quite in depth.
Yeah, it's pretty developed, right? And as we were, so on Friday, we had a quick activity where you transferred a payload. You basically transferred a payload by, and I did this, I demonstrated this in class. I changed the file extension. It did not change the data in the file whatsoever, though. Remember? Does everybody recall that? And that video is going to be posted, but it's going to be limited viewing of that video. Did everyone recall that with each step of that process for file transfer, even once it got on your system, did the hash change?
No, it did not.
No, it didn't.
Didn't change, right? So an adversary can basically change the file extension and then use other systems to transfer a payload into a host, and then from there just change the name back and watch out, right? Now all of a sudden the OS knows, hey, wait a minute, this isn't a comma separated value data file for use in a database or a spreadsheet. It's actually an executable. Now the operating system wakes up with very little effort on the part of the hacker. Now, one of the realities of the process of developing this, and I just want to be very transparent about this. So as I started working through each of the 3 tasks and the criteria, one of the things that I had to reckon with are the related criteria and tasks for the 2.2 assignment and the 2.3 assignment. So I noticed some of you were right on top of the 2.2 assignment and the 2.3 assignment, and that you submitted very quickly. And I think that's great. And what I want you to know, though, is that as I completed development of the solution, I had to go back and adjust some of the criteria for the submission in the 2.2 assignment and the 2.3 assignment. And I want you to notice here, so it says, and originally, okay, so one of the things I want to be sure everybody understands is that when you engage the 2.3 assignment, it may have been 3 points and there were 3 criteria. And now you'll notice the third point, there's been some revisions, right? So the third point is related to an optional criteria. And once again, I kind of had to adjust this around. What I'd like to do is express regrets about how that process played out. We have new resources, and we're using remote access to some virtual systems, some of you, many of you. And in order for me to finish the build on this solution, I had to work through it myself, hands-on, to make sure this stuff would actually work as expected. And along the way, there were simple adjustments that needed to be made, right? So what I'd like to do is change each of these assignments to allow a third submission, okay? And if you submitted early and your first submission did not include the newly revised criteria, fear not. I'm just going to post additional credit if you satisfied the original criteria. But I want you to do a second submission after you finish reviewing this again, okay? Does everybody understand what I'm saying here? So your effort is not wasted. And we're going to honor the prompt attention you gave to this matter. So that remains intact. But what I want you to do is to go back through 2.2, your own submission. And if there's anything in terms of the final criteria for that, right, that differs, then just take what you started, revise your own submission, and submit a second time, okay? I'm going to do that right now. I'm going to modify this so that basically it's a third submission instead of 2, right? I was tempted to allow access to the 2.4 solution only on the condition that 2.2 and 2.3 were completed. But then I thought, no, I don't want to play hardball. But But one thing that I want to be perfectly clear about, and this is really important to know, and I'd really like for everybody to unmute your microphone, and each at a time, I need each of you to say, okay, yes, I hear what you're saying. I don't want to be draconian about it and then list 2.1, 2.2, and 2.3 as submissions for those to be a condition of your access to 2.4, submission access to 2.4. But what I want all of you to do one at a time is to unmute your mic and say, yes, I understand. I need to complete all the assignments before I get into the solution. Could I have that from each of you at this time?
Yep, understand that we gotta complete the assignments before the solution.
Thank you. And I think that was Jadel as well, or no, Luke, was that Luke?
No,
That was
Sulaiman.
That was Sully, okay.
But yes, I understand as well.
Okay, very good.
Sure.
Thank you, Shanoa. I know Milan isn't in Milan dropped, so I'll follow up with him afterwards. Let's take a look at the solution requirements, right? So the goal between the two virtual machines is to create a miniature network environment where you create provocative conditions. So when you're working up in the Microsoft VM, the Python code that opens up 666, right? You're creating a condition that allows for a new Nmap scan to detect that condition. So, and remember that the goal, one of the goals of the module is to practice data collection methods. And then the other goal is to practice digital evidence preservation methods, which is why this FCIV is such a big deal. Okay. We want you to understand and know that folks who are malicious adversaries already know how to do this, and they do it from a terminal prompt with ease. And so we want you to get into the habit of doing that, right? And we also want you to work out of specific directories and folders, because otherwise the consistency of your results could be tainted. So from the first task, we did this partially already in class on Friday. So part of this is already done. But one of the things I want you to understand is that in some cases, you're also uploading the output or an artifact in addition to a screenshot. So let's take each submission point here. So in this case, after you've downloaded this, you change the file extension and move it into the temp folder. And then you capture a screenshot, and it needs to have your first initial, last name, and task 1A, okay? Please do that. It's going to help in terms of consistency for scoring, right? Now, that's easy enough, but what the screenshot should reflect is what? FCI, I mean, it's implied here. We've changed this. I don't need to see this in the downloads folder. I need to see fciv.exe. And which directory is it supposed to be in for this screenshot?
Temp folder on the C drive.
Yes, exactly. So what you're going to screenshot is this. Now you could have other things in there. All right. You could have other things in the temp folder, but I want you to highlight this, and I want you to use Alt print screen so that and don't use the whole screen, right? there's going to be a lot of submissions for this. It's a 10-point solution. That's 10% of your final grade for the whole course. And so if we're all in agreement about how this works, then that's easy, right? And I think most of you already have that. So you've already got this first point for the solution completed, I think. As long as you have a temp folder. If you click up here, you'll see it says C:\temp. And that's an even better way to show it if you can, right? Having it in the temp folder separately is really going to help us later on. Now, there is a README file when you download this thing, and I have not included the README file, but I can email it to you separately or list it as a separate reference, and it talks about how the file checksum integrity verifier or hash tool, right, is used. And one of the things that I want to call out to you right now is that there's a simple way to use it. If you use the default, I think it generates MD5 just by default. But if you want to, it can also generate SHA-1 hashes, which are considerably less likely to suffer from something called the birthday paradox or a collision. Does everybody understand the reference about birthday paradox and collision?
No, I can't recall.
What is the birthday paradox again?
All right, so MD5 is an older one-way encryption algorithm. So hashes by nature are encryption methods that generate a random unique value. And one of the criteria that makes a hash, a cryptographic hash, is that the input for that hash, different input always generates a different output. That's one of the criteria for the algorithm upon which hashing tools are built, okay? The second criteria is that the output is independent of the size of the input. So you could feed a 2 kilobyte input to an MD5 hash, and the output would be so many characters, hexadecimal characters. And you could also feed a 3.4 gigabyte movie, a digital movie, into the hashing algorithm. And what would come out is a unique value that's the same length and the same number of characters as the 2 kilobyte text file, okay? And there's a third quality or attribute of a hashing algorithm that's the most important. It's irreversible. You can't take the hash result and then reverse engineer it or feed it back and then generate the original content. It's impossible. So that's a review of hashing essentials. And what's supposed to happen is that any different file generates a different hash. Now, there are cases where you could take that same hashing algorithm with a different file, and in theory, it would create exactly the same hexadecimal output, okay? So this is called a collision. If I take that 2 kilobyte text file, like this file right here, how many kilobytes is this? How big is this thing? Oh, it's 3.54 kilobytes. Everybody see that?
Yep.
And let's say I take the ISO for server 2022. That's 4 gigabytes. Gigabytes, right? So it's 1,000,000 times larger, right? If I generated the MD5 hash of this, what's not supposed to happen is that if I take the ISO for the server download, the install media, 4 whatever gigabytes, that I get the identical result. If you receive an identical result, that's called a collision. It means that the the hash output values collide or intersect. They're completely identical. That collision is a problem. And in theory, this was demonstrated in theory with MD5, okay? So a collision was actually proven for MD5. And that's why it was retired. And SHA-1 was the outcome. So SHA-1 was an improved hashing algorithm that was used for quite a while. And, you know, as hardware and operating system and coding advances have played out over the last 2 decades, we're talking about 2 decades. So in computing, in terms of the computing profession, 2 decades in computer engineering and computer science, and in cybersecurity is a bit like 5,000 years of evolution, right? It's because of the rapid pace of evolution in computer hardware and software. 2 decades is like a lifetime or more than a lifetime. And so what's happened is that SHA-1 was proven in theory to have a chance for the collision. Now, the whole idea of a collision mathematically is based on something called the birthday paradox. If you have a group of people in a room and you increase the number of people in a room, after a point, there's a tipping point where it's likely that they both have the same birthday. Have you ever experienced that yourself, where you're in a group of people and it's like, oh, today it's so-and-so's birthday, and it's a gathering, it's a group of people, and then somebody else goes, oh, it's my birthday too. You understand what I'm saying?
Yeah, I've experienced that.
Okay, so what are the odds? What's the probability that 2 people in any given group would have the same birthday and they would experience the same birthday on the same date, right? Take it a step further. They were actually born on the same day, on the same date, in the same year. That's even more, right? That's even more of a paradox. So mathematicians have basically fleshed out the idea that there's a certain tipping point. Past a number of individuals, the odds are pretty good that you're going to find somebody with the same birthday. It's the same idea conceptually that applies to hashing algorithms for collisions. The inputs, in theory, should always be different based on the encryption algorithm, but it doesn't always work that way, okay? Does that explain? That's also written up in your textbook. It's also explained in your textbook, okay? Does that answer your question about the birthday paradox and collisions?
Yeah.
Okay. Now, we're going to be using SHA-1. So we're going to be using SHA-1, and we want you to use fciv.exe. And there's a simple syntax that allows you to distinguish between generating the MD5 versus the SHA-1. So MD5 is default. If you use it, FCIV is quite literally a command line utility. So what am I saying? I want you to watch this. I'm going to double click this. Has anyone ever tried this yet?
Not yet, no.
All right, I want you to watch the screen carefully. You'll probably see a short flash. Did you see that?
Yeah, I saw it.
Okay. The reason that occurs is because this is not a utility with a GUI. It doesn't have a graphical user interface, right? It's not intended to be there. So what you have to do is open a command prompt as an administrator. Can everybody see the window?
Yeah.
So if you wanted to and you were lazy, you could actually use this window and the command prompt in concert so that you wouldn't make any mistakes. But what you can do is you can click on here, and then I'm going to right click and copy this. And then I'll go over here and I'm going to change my directory into the temp folder, okay? So CD, and then I'm gonna paste. And now I'm in the temp directory, okay? If I list or work a directory, I should have the same values on the screen that I see otherwise, right? So I see SQL Server, Developer Edition, right? And it's a certain size. I see FCIV README, I see FCIV other, right? We good? Everybody there?
Yep.
Yeah.
So let's use the FCIV -readme.txt file. Actually, let's use this one. The Windows this is the Windows executable that was located in the Wayback Machine from a historical capture of Microsoft's website. You can't find this or get this anywhere else anymore, right? So they just pulled it from the shelf and said, okay, we're not doing this in the public anymore. But hackers know about it, and hackers can do stuff with it. And to the extent that, I guess because it's limited to SHA-1 and it's older, that's one reason why they pulled it. So what I'm going to do is copy this with a right click. So now it's in the clipboard, the name of this file. And if I use, let's see, the /v option, that'll verify, and then the -SHA-1 option, right? Then it'll generate the SHA-1 result of that file. So I should be able to take FCIV and then -v -SHA-1 and then the name of this file. So FCIV dash, let's see, am I doing the file first? Yeah, I'm doing the file first. So I'll paste. Then I'll do a -v -SHA-1. Let's see. Didn't like that. It says missing flag XML. I'm going to leave the -v off because I want to keep this simple for a demonstration, okay? Everybody with me?
Yeah.
Everybody see this?
Yep.
That, what I just demonstrated is what you'll need to do on occasion in your tasks for the solution. So yeah, don't worry about the -v switch. We don't want to collect in XML format. Okay, so what I want to do is see whether or not this works. So I'm going to right click this again to copy it to the clipboard. And I'm going to go ahead and open a new tab in my notepad and paste this. Now I have an independent hashing utility, so I should be able to go here into hash tool, select SHA-1, and then select the file in the temp folder. Does everybody see what I'm doing here? And it's this file, which is 119 kilobytes. So that's the SHA-1 hash, generates very quickly. I'm going to copy this. Let's see if it matches. Oh, look at that. So the SHA-1 hash matches whether it's generated with the the hash tool version 1.2, or if I'm using FCIV. But this is one of the criteria you need to satisfy for your submission for the solution. Any questions about what we've just shared here? So you have a screenshot of fciv.exe sitting in the temp folder. Then you download any safe media. So what I want you to do is to put anything, any safe media file, right? So it could be a picture, could be a video, could be a sound file. Don't make it very large though. And then move it into the same folder with FCIV. Now you just saw me do this with the knowledge base executable to install FCIV. So I demonstrated this next part by using this file, right? Now, you're going to generate the SHA-1 hash with FCIV, just like I showed you, and you're going to capture an image like the one displayed, but then you're going to rename the media file you chose to task1download.xyz, okay? So what are we saying there? The name of this file is this, and I'm going to copy this, and I'm going to make a record of this. That's the original file name, okay? But I'm going to change the name of the file to task1download.xyz. Does everybody see that? So if this were your media file, this is what I'm going to do. It says, hey, if you change the file name extension, the file might become unusable. Are you sure you want to change it? Yes. So what are you doing? You're uploading a picture of the hash that you captured with your name and the label task1b, but then you're also uploading task1download.xyz. Now, why do you suppose I'm requiring you to do that? What do you think I'm going to do with your file?
And run the hash.
Yeah, I'm going to run the hash against it. And I'm going to see whether or not I get the same hash you're showing on your screen. And do you get, let me just ask a question. Do you think you'll receive credit if they don't match?
No.
No, you won't. Good answer. So what are we saying? When you upload your media file, I'm gonna generate a hash, and I'm gonna see if it matches the hash that's displayed on your screen. I'm gonna do this like we just did. And if it matches, then you get credit. I want everybody to understand what's going on here with this process. Okay? Any questions about what we're doing? All right. In the time remaining, let's go ahead and walk through the firewall rules and network exposure, okay? So, yeah, this is what you're doing on the Microsoft VM. You're going to set up two custom firewall rules. The first is a general firewall rule that allows inbound traffic for TCP and UDP ports 1, 2, and 3. And in fact, those are actually two separate firewall rules. You'll have to set up one for TCP and one for UDP from any host on the local network. And then you'll create a second firewall rule based on the pinhole access for TCP and UDP for ports 456, but only for connections from the gateway address on the local network. So let's take a quick look at this. So for part of your solution, you'll need to have the Kali machine and the Microsoft machine running simultaneously. Does anyone know what a pinhole firewall rule does?
It only allows a certain IP address to get through the firewall.
Correct. That is correct. So the one is to set a general rule, right? And the other is to set up a pinhole rule. And what we want to do is to see if those firewall exposures will result in artifacts with GRC and with Nmap, okay? So once again, what we're going to do in task 2 is set up firewall rules, custom firewall rules, one that allows any traffic from any host with port TCP port 123 or UDP port 123. And then we want to create a second set of firewall rules for ports 4, 5, and 6, but those will only be allowed from, so if the gateway of your home network were to probe with an Nmap, then it would be able to see that, you know, okay, there are openings on port, you know, there's the ports 4, 5, and 6 for TCP and UDP connections are unshielded. That's what an Nmap discovery against, if it were run from the gateway, from, now most of you have a gateway of like 192.168.0.1 or 192.168.1.1, right? So it's only your gateway that could run Nmap scans against your server to see whether or not 456 is open. But 123 is configured differently. So let's take a quick look at this and then we'll be done for the day. Just understand that after that's set up, you're using the Kali Linux machine to run Nmap, right? So that's what we're doing. Now, when we say that we want you to capture the Nmap output using the current date, what we're saying is that you're going to run an Nmap command and you're going to use the redirect symbol, a single right arrow, to save it with a name that's the date. So that way you can retain the text file that's created, and more importantly, you can hash the Nmap results. So you're labeling the hash output, you're labeling the Nmap scan, it's redirected into a text file. That text file is hashed using the SHA utility, and that way you'll have a record of the hash value for that Nmap output, okay? So we'll show you what we mean by that in just a moment. Any questions so far? Can everyone see my screen?
Yeah, we can see your screen.
All right, so if I go here into control panel, and then I go into the firewall and go into advanced settings and inbound rules. Can everybody see this 1, 2, 3 here?
Yeah, we can see it.
So I've walked through the wizard to create a new rule. I called it TCP123-CSC443, so I know what the heck it is. In the scope tab, I've left the default settings in place. Any IP address, any IP address. Everybody see that? And in terms of the ports, when we're looking at this, it's TCP123. That's what I have. Now, if there were a way to simultaneously select UDP, you could have one rule. But I have two rules, and they both allow TCP and UDP on 123. And the scope tab says, okay, I'll accept connections through those ports from any other host, okay? Now, what about this connection, the 456? Same thing, I have TCP 456, but now when I look at the scope, this is pinholed to my gateway address. So unless a connection request originates from my gateway, the firewall is it's not gonna allow it. Meaning the only unshielded port is the one right from my gateway. And I want to see if I can detect port 456 on my host with Kali, right? Now, let's look at Kali real quick. If I go into Kali, and do I need to tell anybody that you got to run updates and apt-get, update, ampersand, apt-get, upgrade? Everybody knows this, right?
Yeah.
All right, can everybody see this?
Yeah, we can see it.
Okay, so this is the name that I chose when I was running Nmap. I ran an Nmap scan to the subnet, the local subnet. So it was Nmap, a simple scan. So no switches. Nmap 192.168.1.0/24. Then I had a redirect sign. So I had a redirect symbol. That's the right arrow, right? And then I put this name down. So if I basically use the cat command to look at nmap dash 21 October 2023, and that's the date, right? It's case sensitive. What I get is the content of the nmap scan on my screen. Can everybody see this?
Yeah, we can.
Now, here's the fun part. Look at this bad boy right here. Telnet, the use of Telnet was deprecated, meaning retired, because it's extremely vulnerable. Yet in my own home network environment, my network environment, I mean, I'm the instructor for the cybersecurity program at the University of the Virgin Islands, right? What are you seeing here? Oh, there's a device and it belongs to what? D&M Holdings? I don't know what the hell that is. I have to look that up with the MAC address to find out what that is. Here's something else that's interesting. Ooh, look. So the Nmap tells me whether or not I have virtual machines active in my network environment, right? So I want you to look at the results that you're getting from your Nmap, and I want you to begin to determine if you have anything provocative or unusual in addition to the deliberate settings, right? Here's 6666 IRC. That's another bad one, right? And these aren't things I intentionally set, but I also have my server. I have my server address that's going to reveal certain things about what's running on my server. So that's what we mean by capturing to, when I say capture, you're running Nmap, And it's to that entire subnet. So I could say 192.168.1.0/24, and then I redirect to this text file with today's date. So today's date is the 23rd of October, right? So now it's October 2023.txt. I hit enter, and that's what I'm doing. You're supposed to hash the text file. So what are we saying? One of the things you want to be able to do when you generate that text file is to create a SHA-1 hash of the text file. So it has a date time stamp, you know the context, you understand what it scans specifically, and more importantly, you have a SHA-1 hash. So now you have proof whether or not that output file has changed in the future. Put another way, you have validated evidence you collected so that if it's modified or altered, you can basically exclude it from consideration in a court case. Or if the hash remains unchanged, you could say this is an authentic record. It remains unchanged, untainted. The data is unmodified. This is an authentic capture of Nmap, and it's allowed as digital evidence. Does everybody understand what I'm saying here?
Yep.
All right, this concludes our review of the solution. The task 3 is self-explanatory, but if you run into any snags, let me know. We'll see you on Wednesday. Remember, Wednesday is a big day. We'll be talking about firewalls. Everything and anything you wanted to know about firewalls. See you then.